All right, welcome to tonight's video on 1.5, part 2. We're going to talk about how to evaluate limits analytically, which means using algebra. All right, so basically, whenever you're evaluating a limit analytically, you're just going to basically substitute in the number. So for example, if you're finding the limit as x approaches 3 of this function, you are just going to put the 3 in, substitute the 3 in, and so you would get 9 minus 12 plus 1, so negative 3 plus 1, which is negative 2. The limit as x approaches 7 of 10, well, since 10 is a constant, it is just 10. There's nothing to substitute the 7 in. Here, when I put in the 1, I get 1 to the third minus 1 over 1 minus 1, so therefore it is 0 over 0. Whenever it's 0 over 0, that gives us what's called an indeterminate form, meaning we have to do something else in order to figure out what the limit is. So what we can do is we can take the function x to the third minus 1 over x minus 1 and simplify it. Because x to the third minus 1, remember when you have the difference of two cubes, when you factor it, that becomes a minus b times a squared plus ab plus b squared. That is the difference of two cubes. The sum of two cubes would be a plus b times a squared minus ab plus b squared. Remember, the sign here is same. In the middle, it's opposite. Last one's always positive. So for the top here, it would be x minus 1, and then it would be x squared plus x plus 1 all over x minus 1. So if you notice, this cancels, and it leaves you with x squared plus x plus 1. So now the limit as x approaches 1 of x squared plus x plus 1 is equal to 1 squared plus 1 plus 1, which is 3. So whenever you have an indeterminate form, you're going to do algebra to simplify that function and then stick the number back in, and that will give you the limit. So for example, here it says the limit as x approaches 2 of this function. So let's put 2 in. So 2 to the third minus 2 times 2 minus 4 all over 2 minus 2. So that gives us 8 minus 4 minus 4, which is 0 over 0. So once again, that's indeterminate. So therefore, what we have to do is we have to do algebra to simplify this. Now you might think, well, how do I factor this because it's to the third? Well, we're not going to factor it, but what we can also do is we can divide x minus 2 by x to the third minus 2x minus 4. The quickest way to do that is synthetic division, where you take the 2 and then divide it by 1, 0, negative 2, negative 4. And notice, bring down the 1, bring down the first term, then you multiply, you add down, multiply, add down, multiply. Notice the last one is the remainder. So this becomes x squared plus 2x plus 2. So when you factor this, it's x minus 2 times x squared plus 2x plus 2 over x minus 2. So basically that gave us the factorization of the cubic by using synthetic division. So then we can cross this out, and this becomes x squared plus 2x plus 2. So when we find the limit now, as x approaches 2, we're finding it of x squared plus 2x plus 2. You substitute in the 2, so you get 4 plus 4 plus 2, which is 10. So that's another way you can factor by doing division. And if it goes in evenly, then what you divided by is one factor, and what's the resulting polynomial is the other. Now here, we do 3 minus the square root of 9 over 9 minus 9. So notice this is 3 minus 3 over 9 minus 9. So it's 0 over 0, which is indeterminate. So now, in order to simplify with a radical, you don't factor, but remember with a radical, we multiply by the conjugate. So remember, when we multiply by the conjugate, we multiply the first and the last. So 3 times 3 is 9. And then minus x, because negative root x times positive root x, all over x minus 9 times 3 plus root x. Remember, when you multiply by the conjugate in the bottom, you leave it multiply like factors. You don't multiply it out, because x minus 9 and 9 minus x, they're not the same, but they're opposites. So to cancel them out, you'll put a negative 1 here. So it's negative 1 over 3 plus the square root of x. So when we take the limits as x approaches 9, we are now taking it of negative 1 over 3 plus the square root of x. So it's negative 1 over 3 plus the square root of 9. Negative 1 over 3 plus 3, which is negative 1/6. All right, so let's look at the next one. We put in the 0, and we get the square root of 49 minus 3 times 0 minus 7 all over 2 times 0. So the square root of 49 is 7, so it's 7 minus 7 over 0, which means it's 0 over 0, which is indeterminate. So now we have to simplify 49 minus 3h minus 7 over 2h. So multiply by the conjugate, 49 square root of 49 minus 3h plus 7. So when we multiply here, square root times square root removes the square root sign. And then negative 7 and positive 7 is minus 49 all over 2h times the square root of 49 minus 3h plus 7. Well, the 49's cancel, and then the h's cancel here, so you're left with negative 3 over 2 times the square root of 49 minus 3h plus 7. So that is what we're going to use to find the limit as h approaches 0. So it's negative 3, and then 2 times over 2 times 14, which is 28. Yep. So that's how you would find the limit if you get 0 over 0 or indeterminate. Otherwise, if you substitute it in, it gives you an answer like in number 1 or number 2, then you go with that. Now the piecewise function, when it's a piecewise, remember, you're finding the limit as x approaches 3. This is a changing point. So if you're evaluating the limit of a piecewise function at the changing point, then you have to find the limit as x approaches 3 from the left. And from the left is less than. So that's x plus 8. So when you put 3 plus 8, that gives you 11. And you also have to find the limit as x approaches 3 from the right. From the right is greater than. So you're going to use 2x squared minus 7 and put the 3 in. So this becomes 2 times 9 minus 7, which is 11. So notice, since it's the same, the limit then as x approaches 3 of this function is equal to 11. So that's the process when evaluating the piecewise function at a changing point. Notice here, this one is saying the piecewise function, it's 4 minus x if x does not equal 2, and if it equals 2, it's equal to 0. So basically, if you think of this graphically, 4 minus x is a line that goes down, and then at 2, you have a hole, right? And then basically you're going to have a point. So if you look at it, the limits as x approaches 2 here, it's going to go towards whatever 4 minus x is. So 4 minus 2 is equal to 2. All right, so that concludes our video on evaluating the limits analytically. If you have any questions, I'd be happy to answer them either at iBlock, before school, or during the next class. Have a good evening.